Now coming to question number 5, which says a subset S of the plane is called convex if given any 2 points x and y in S. The line segment joining x and y is contained in S. A quadrilateral is called convex if the region enclosed by the edges of the quadrilateral is a convex set. So what they are trying to say that if your quadrilateral or a convex set is such that you join any 2 points of it, an entire thing is lying inside the region, something like this. But if you draw a quadrilateral like this, in this case you can see if you join these 2 points, okay, then the portion of line joining these 2 points is lying outside the region. So this will be concave, and that will be convex. That will be convex. In fact, one more thing you can see that for any convex quadrilateral or polygon, this angle has to be less than 180. Every angle should be less than 180. But in case of concave, you may have one or two angles that are greater than 180 also. Okay, so this thing was only to explain you what is convex set. Now they are saying, show that given a convex quadrilateral Q of area 1, there is a rectangle R of area 2 such that Q can be drawn inside R. Now I will make 2-3 cases for this thing. First of all, we should understand for any quadrilateral, we have to have at least one of the angle that is greater than or equal to 90. So I'm making one quadrilateral, something like this, and you can see one of the angle is greater than 90. Maybe I can ignore that this is not greater than 90. You can think of that it's acute only. Actually, my purpose here is that I will be drawing a diagonal like this. Let me call this quadrilateral as ABCD. Okay, and then what I'm going to do, because these two angles are acute, okay, so I can draw a diagonal passing through A and C, and then I can draw two lines. So two lines, one passing through B parallel to AC, and one line parallel to D and parallel to AC, and then we can draw a rectangle like this. This rectangle is such that this line joining A is perpendicular to AC, and because these three lines are parallel, so here we will get a rectangle. These two sides are parallel and these are perpendicular to AC. Now what you can see, suppose I call this rectangle as PQRS. Okay, so it can be seen that area of this PQCA is 2 times the area of triangle ABC. It is direct conclusion from the fact that base are same, height is also same, but because one of them is rectangle, one is triangle, so that because of factor of half, this PQCA will be 2 times. Similarly, area of rectangle ACRS is 2 times area of the triangle ACD. Okay, now if I join both of them, I think we get, if we add both of them, we get area of PQRS, and that is equal to 2 times area of this quadrilateral ABCD. And this is 1, so this becomes equal to 2. So you can see that we can have a rectangle of area 2, so that this Q, that is quadrilateral Q, is drawn inside the R. So that is one of the case. Okay, now I'll tell you a few more cases, because here we assumed that these two angles are acute, or at least rectangles, the diagonal AC was such that the two sides passing through this vertex A and through C, they were making these angles, let us say alpha, beta, gamma, delta. They all were acute. Why I'm saying so? If alpha is not acute, alpha is obtuse, then the rectangle we would be making, that will be lying outside the quadrilateral. Let me show you the another diagram. You can see here I have taken this quadrilateral is ABCD. This is B here, quadrilateral is ABCD here. Now you can see this one is right angle, this is obtuse, and this one is also obtuse. Now if you join, the diagonals, you may not be able to make rectangle the way we made in case number 1. Okay, in case 1 what was important? These angles AB, alpha, beta, gamma, delta all were acute. Here you may not get, like if I join B with D, let me just try with this way. Okay, and because this angle, if it is obtuse, you can see my rectangle will be going like this, and in this case this quadrilateral will be going outside. So this case, I think that previous method will not work. Then how we can do it? Let us see. In this case, what I have done, ABCD is a quadrilateral, that given in the question, and I have drawn a rectangle whose base is AD. Okay, and from AD actually both the angles are acute, alpha here, and maybe I can call this as gamma here. Okay, and then through C I have drawn a line parallel to AD, and then from A perpendicular to AD, and from D perpendicular to AD, lines are drawn so that PQDA is a rectangle. Okay, I think simple observation may do this question for us. Please see, I have drawn perpendicular from C to AD. Similarly, I have drawn a perpendicular from B to CR. Okay, and similarly this is perpendicular to this. In fact, all these lines which we are seeing, they are perpendicular to the line of their intersection, at their point of intersection, you can say. Now here you can see this area, if it is A1, this also has to be A1 because CQDR is a rectangle. Similarly, this area, if it is A2, this will also be A2. Similarly, if this is A3, this is also A3. So now you can see my area of quadrilateral, that was 1. Okay, area of the quadrilateral is actually A1 plus A2 plus A3 plus A4, and this is equal to 1. Whereas area of rectangle in this case is actually 2 times A1 plus A2 plus A3 plus A4. Okay, but I think in this rectangle, uh, in this rectangle, A4 is only once, so I will be subtracting A4, and there is A5 outside, that is also included, which was not there in the quadrilateral. So if I am able to prove that A4 is bigger than A5, I think we can say this area of rectangle will be lesser than 2. Okay, now do this thing. What I am going to do, I have drawn this angle as alpha and this angle as beta. Now you can see alpha has to be greater than beta. Why I am saying so? Because this line is parallel to this line. Even if this AB was extended like this angle would have been same as alpha. And because it's a convex quadrilateral, so this angle beta has to be lesser than alpha. I hope that is clear. Now please see. This A5 area, is actually, you can see, length from this place to this place. I can call this as AB into cos alpha. This one side, A5 is this equal to this, so AB cos alpha into the other side is BC sine beta. BC sine beta. Okay, and A4, if I do, A4 is this thing, it is actually opposite. You can see it will be AB sine alpha into, that will be BC cos beta. Okay, now you can see that A4 minus A5, if I do, that will be AB into BC common, AB, BC common, and what we are getting? We are getting, I think, A4, I have written this as first, so I think this comes out to be sine of alpha minus beta, if you can check. Okay, and because alpha is a bigger angle than beta and they both are acute, so this has to be positive. So that means A4 is bigger than A5, and hence this area of rectangle will be less than 2. So you can see in this case we have drawn a rectangle whose area is even lesser than 2, and it is still able to contain this quadrilateral. So in this case, when two angles were obtuse, okay, we have done this way. In convex polygon, convex quadrilateral, actually there is one more possibility, that we may have three internal angles to be obtuse, 1, 2 and 3. Third has to be acute in that case. I think in this case it is much easier. You can see this ABCD is the polygon here, ABCD is the quadrilateral here, and let me call this as P, Q, R and D. P, Q, R and D as the rectangle. So you can see the area of quadrilateral, which is A1 plus A2, A1 plus A2 plus A3, and there is one more left out area, that is A4. So A4, that is equal to 1. Whereas area of rectangle, if we see, it will be 2 times A1, which covers this and this, plus 2 times A2, which covers this and this, plus 2 times A3, which covers this and this, but only A4.